All right, good evening. What do we got? 3 of us at the moment. Probably just waiting for a few more to come on. Can I just get a sound check, please? G'day, Pat. How you going? I'll just get my chat box up and running. Yeah, if someone can just let me know that they can hear me okay and the sound's coming through. Right, let's flick that out. Sound is good. Hello, excellent. All right. So we're recording this. We're just going to kick off anyway because I want to be done by 8 o'clock. It'd be great. I assume everyone else will log on as they're going. All right. So what we're going to have a quick look at today is the people. And it's a good idea to jump onto the website every now and again and update the software that you've actually got. Only because Pico tends to modify and change and fix little bugs every now and again that might be causing us some grief. So with the new Pico 7 software that they brought out, the beta version, which is the tablet-based, they did have some issues with it, and they've done an update for that recently. So we're actually updating all of our tools that run the beta-type software. Now, again, if you look in your files folder, I'm just going to share this. Share. Okay, so if you look down the right-hand side of the screen, you'll see we've got files, and I'm now sharing the PDF version of the presentation tonight. So feel free to download that and print that out if you will. Pat, the one I sent you the other day, I've just moved some of the slides around a little bit, so you might find it slightly different. All right, I'll keep my chat box open as well. Again, just ask me any questions as you come or as you have them, and I'll answer them as we go. All right, let me get back to, which one am I looking for here? That one. All right, so Pico software, it's free. It's fantastic. As someone once said, the best things in life are free. Well, here it is, Pico software. You can download that to any PC or laptop. I find it a great tool, very, very good for training, but also great for the reference waveforms that they have. Now, you don't have to have an oscilloscope to be able to download this software. Just go straight to picoauto.com and download the latest version. Now, when you download that software, you'll actually end up with 1, 2, 3 different software shortcuts on your desktop. And those shortcuts, let me just get mine up. Here we go. Let me share my screen. Here we go. So these 3 are the shortcuts that you'll end up with. Pico Diagnostics, Pico 6 Automotive, and Pico 7, the beta version, which is the light version of, let me just get these over here. I'm a bit OCD, I like things in order. And this is the light version of the Pico software, and that works on tablets. So we've been using that on the tablets that we sell with our Elite kit. It seems to work fairly well. I prefer a bigger screen, so I put it on the laptops. All right, let me get back out of this. Stop screen share, get back to my slideshow. How do I get back to my slideshow? Where to go? Stop, start, start. Here we go. There we go. That's a bit of stuffing around. So that's the software you want. And that's what you'll see, the download Pico 7 beta version. And they've got a new one of those out at the moment. All right, so we're going to have a quick look at Pico Diagnostic software. So this is the first version. So Pico Diagnostics is a great bit of kit because it's quick software. It's all about doing some very quick tests. And these are the tests that sort of replace what we used to do 20 years ago. I remember my boss used to tell me to check the basics first. You know, a car came in for a tune-up or it was running bad, check the battery, make sure the battery's not flat, check the compression, you know, before we start replacing plugs, leads, coils, anything like that. Do the basics, make sure that the exhaust isn't blocked, make sure that, you know, the air tract isn't blocked, there's no plastic bags clogging the intake. So they're the basic things that my boss used to tell me to do. And the great thing is Pico have put them into this bit of software, which is very, very simple and it's very, very quick to use. So we're going to have a quick look at some of these. And the first one in the Pico software, on the Pico Diagnostic software, is the battery cranking test. So for those of you that are using this already, you probably find it's pretty good. I don't mind it because it is fast and it's very accurate as well. So this is all about start lining accessory batteries. So you start battery or you crank battery. So once you open Pico Diagnostics and we click on battery test, all right, and this is the screen that'll pop up. These are the connections you make. 2 channels, positive, negative on your battery and the high amp clamp. So we do have to make 2 connections. Now the Pico show this on the positive cable. It really doesn't matter whether it's positive or negative. All the current flows through the circuit. It flows out the negative, down that way, back in the positive. And that's the way electrons actually flow out of the battery, always out of that negative side. So it doesn't matter if we're on this positive cable or we're on the negative cable. You will just need to flip the clamp around to get an accurate reading. Do whichever one's easiest. It works both ways. Okay, so what we've got here, I wonder if can I click on that screen? That's a video. It doesn't actually want to play. So once we've done our connections down here, there's a few other little things we've got to enter into the Pico software. So I'm just going to get my one up and running so that I can see. Again, suffering from a little bit of old age, and I can't quite see what's on the screen anymore. But luckily, that's why I sent you guys the files. All right, so what we need to do at the bottom of the screen is just enter some battery details, the type of battery, CCA rating, what else we got? The temperature of the day, the ambient air temperature. So we put those details in and we press start. And as we press start, it starts to record the screen. We then crank the engine and let the engine start. And this is the pattern we'll get at the end of it. It's a nice quick test. It takes about 10 seconds. And we actually have 2 channels. So we have a channel here for voltage and a channel for current. And we can actually see that they should mirror each other. The cranking current goes up, and that's in the red. So as we hit that breakaway of the crankshaft starting to spin, the current flow out of the battery is at its peak. And that's what we sort of look up here. But that's also when we get the massive or the biggest voltage drop out of the battery. And that's when we see our battery voltage sitting up here at 12 volts. We see it drop down. And these two should mirror each other. Now, as we let go of the starter motor and we start to put charge back into the battery, we don't quite see so much drawn out of the battery on our current flow. But we see our voltage pick back up, and then over here we see it increase again as we start to put voltage back into the battery. Now, once it starts to test, the engine start and run, again, about 10 seconds, we get a report on the battery down here, and it'll tell us whether it's good, bad, or needs charging. And it's very, very accurate. It is a lot more accurate than what we find on those handheld battery meters, the capacitance type ones. I've used the snap-on ones, and they are very good, but they are a capacitance. They use an algorithm based on surface charge and discharge. Again, similar sort of technology is what Pico is using. I just find the Pico stuff a little bit more accurate. It's far more accurate than the ones that you get with the that you buy from the battery companies, and they've got a little printout scroll on the end. And they're good if you sell batteries, because they will tell you every second battery's failed and you need to replace it for the customer, which is great for profit, I suppose. But the Pico software is very, very accurate. So, like we said, if we look on the left-hand side of the column, battery test is the first one we need to do. And whenever we do diagnostics, or we're looking for a fault, or we're even doing an inspection on a customer's car, we should always do a battery test. The next one underneath there is the compression test. Once we know the battery's in good condition, the charge system's working, we then move on to our compression test. Now, this is a relative compression test. It's not an actual compression test or an absolute compression test. But the idea of doing a quick relative compression test, it gives us an idea whether we should be looking for a mechanical fault, an electrical fault, a fuel fault. And it tells us which way to go. And the idea of it, it's just quick. You know, if we do the test and everything comes up in the green, we move on to our electrical or fuel. But if we do the test and we have one of these cylinders pop up in red or yellow, then we need to look a little bit further. And that's what might guide us to do a cylinder leakage test, or guide us to do an absolute compression test. So nice and quick, really easy. We've just done our battery test. Well, you can see the connections are still the same. We're just not using the amp clamp on the second channel. So next thing we do is we select, we've got our connections made. We select compression test from Pico Diagnostics again, and we want to select the number of cylinders. All right, so this being I can't even read that. What is this, a 6-cylinder engine we did, or an 8-cylinder? It looks like an 8-cylinder we've done on this test. We then hit start, and the software will give us a little pop-up box, and it'll tell us to hold the throttle wide open while we do our cranking test, which is what we do with the normal mechanical test where we pull the spark plugs out. And the reason we do that is so that we get a full air charge every time. Now, if you're doing a compression test on a diesel, you don't need to hold the throttle wide open because it already is. They're full air engines anyway. But observe all the normal rules when performing compression tests, and that is stopping the engine from running. So disconnect the coil, disconnect the trigger to the coil, disconnect the fuel pump, run out of fuel, or on a diesel, you can just pop the injector harnesses off before you crank it over. Right, so on this particular vehicle, we've done that. We cranked it over, about 6 seconds worth of cranking, and these are the results we got. Now, this is an actual test I did down in Sydney, and it was on a V8 Land Cruiser. And we were looking for a misfire in this particular vehicle. So we can actually see this is a relative test. So what it's doing is comparing all the cylinders to each other. And it actually showed us that one cylinder was low, and it's down in the yellow. Anything below about 80%, we go to yellow. Anything below about 60%, we go to red, and that's a definite cause for concern. So this basically told us that we had an issue in this V8 diesel, and we need to investigate it a little bit further. But that was quick. It was 10 seconds worth of work straight after we did our battery test. Okay, the next piece of software we generally look at is the absolute compression test. So we would do an absolute compression test again in the Pico Diagnostic software, only if we've got a problem here. If these were all in the green and they were all good, we wouldn't bother. We wouldn't break out the manual compression gauge or the pressure transducer. We just wouldn't do it. We don't need to. In this case, compression's a bit low, so we're going to check them. All right, so to perform an absolute compression test, you need this kit. You need the additional piece of hardware, which is the WPS 500X pressure transducer. Now, if you're doing petrols, they're pretty good. All the piping and hoses and the adapters for spark plugs are in here. They no drama at all. If you're doing a diesel compression test, you need the diesel glow plug adapter kit or injector adapter kit that goes with this as well. It's an additional piece of hardware you need to buy, but it's worth it. It saves a lot of time. Now, the reason we do it with this type of piece of hardware rather than a manual compression gauge is because if I go back to this diagram, this is an 8-cylinder engine. Now, being a diesel, I've got to pull all 8 glow plugs out or 8 injectors out, and then I've got to mount or screw in my high-pressure compression gauge and do one test at a time until I find the one that's low. When we do an absolute test with this piece of software, we only need to pull out one spark plug or one glow plug, and it's usually number 1. And we pull out number 1 because basically, when we get a reading on number 1, we can work out the firing order from there on. Now, the software is very, very good in Pico Diagnostics. It can tell us by entering a few little bits of information and plugging into cylinder number 1, we can get a very, very good absolute reading on all cylinders. Connection's nice and easy. Channel A, B and C test lead. Test lead to battery positive and negative, channel B, B and C, cable to pressure transducer. Pop out number 1 and put your adapter in there. All right. I thought we just saw that hardware connection. Oh, that's our connection there. So they've gone to channel A with the pressure transducer. We've gone channel B and we're using A as a battery. This particular one there, remove the spark plug, glow plug. It doesn't have to be the misfiring cylinder, it can just be cylinder 1. Connect the adapter to pipe, disable fuel ignition. So if we go back to our relative compression test, we've already disabled the fuel source or the ignition source, so the car won't start or the vehicle won't start. All right. So we perform this again via compression test. We select compression test in Pico Diagnostics. We do need to select a few different bits of information there. So in our drop-down box in our settings or options, we get a little drop-down box here. I'll just see if I've got a picture of that drop-down box. I do. That'll be up next. We select pressure and we select number of cylinders. In this case, it looks like we've selected 4 cylinders. All right, let's go to the next one. This is our options, our drop-down box. Now, what it wants us to do is just enter a few little details. Now, it needs this information so the software can do its absolute wonders and work out the absolute compression ratio of every cylinder, even though we're only checking 1. So those values are cylinder volume, this being a 4-cylinder, 2 litre, the cylinder volume is going to be 500 cc's. We need to know the compression ratio, and we can get that from any sort of online data source or in our lube and tune-up guides. The sensor volume, now this is the volume of the WPS 500X sensor and hose. Now, if you're using a very long hose and a very long adapter, this will change. Now, the book that comes with the hardware kit will actually give you the volumes of each of the pieces of hardware, and we can just add plus or minus that volume as we see fit. Now, this is the engine capacity 2 litre, and we're using the pressure sensor. So we tick that box. We go next. We hit start. It prompts us to crank it over, hold the pressure wide open, hold the accelerator wide open, and this is the value we got on this 4-cylinder engine. So, and this is an absolute reading. So cylinder A is cylinder 1. Now, this being a 4-cylinder engine, we've now got 1, 3, 4, 2. Because that's our firing order, that's the way it works it out. And this is an absolute, and this works. I know it sounds a bit weird only checking 1 cylinder to get pressure values on all of them, but I've tried this and I've tried to fool it on 3 or 4 different motors where I've moved it around, I've put it in different locations, I've tightened the valves up on an engine so I actually get one to leak. Not the one I'm testing, and this reads exactly the same. I've put a manual compression gauge in there and got exactly the same reading. So I'm very, very confident this system works very, very well. All right, next one. Next thing we do, if we've got our misfire, we might want to do a cylinder balance test, and just to locate the misfire. So a compression test will let us know if mechanically we're low on pressure. But if we think back to our first initial relative compression test we performed, let's say the car's got a misfire, it's sitting there running rough, misfiring. We do our relative compression test. They all come back good. They're all in the green. Well, then we probably wouldn't do the absolute compression test. We'd go straight for a cylinder balance test. And the idea of the balance test is to work out which cylinder is actually misfiring. So this is no different to what we used to do when we pull the spark plug leads off one at a time. And we just see which ones. We watch the RPMs or listen to the engine ticking over, and as we get to the cylinder that's running bad or misfiring, it won't make any difference when we pull that lead off. Or when we disconnect the petrol fuel injector, we could do it that way. Be very, very careful if you're doing balance tests on diesels. So old school diesels where we crack an injector pipe, that's a balance test. That works well. Don't crack an injector pipe on a common rail diesel. They don't like it. And there are fairly high pressures there that can cause some issues if the diesel gets anywhere near. The other thing you don't want to do on diesels is disconnect on a late model common rail diesel, is disconnect the fuel injectors while it's running. It might be okay on a solenoid type diesel injector, but if you're doing it on a piezo injector, you're asking for trouble. The thing with piezo injectors, we use current flow from the injector driver or the ECM in one direction to open the piezo. So we expand the stack to open the injector. But then inside the ECM, we reverse the current flow and power up the injector, and that basically closes the piezo stack, which allows the injector to close. Now, what can happen if you're pulling injector harnesses off the injectors while the engine's running, and you do it on a piezo diesel, you run the risk of popping that injector harness off while the injector's open. Now, no spring in the world will collapse that piezo stack once you remove current. The only way to collapse that piezo stack is to run the current through that injector in the opposite way. Now, the bad thing is if you've got the engine running and we pop that off, well, we'll dump all fuel pressure into that cylinder, which means the rail pressure will drop, the engine will flame out. You can run the risk of, if the cylinder's hot and we pop that wide open, we can put a hole in the piston. So be very, very careful doing it that way. Best thing you can do if you're doing a balance test in that regards with your scan tool, you disable it electronically, and that cuts each injector and actually tells you which cylinder is misfiring. But the idea of the PicoScope, it does it for us. Now, it's very clever because the way it does it, again, straight across the battery. Now, what it's actually doing is measuring the amount of torque that each cylinder is applying to the crankshaft, but it's doing it through the alternator. Now, every time, if we look at a four-cylinder, you know, we've got a firing stroke every 180 degrees on a four-cylinder, you know, 2 up, 2 down. As they spin around 180, we'll have another firing stroke. So what will actually happen is the alternator will spin fast, slow in relation to the crankshaft in those power pulses. And what this is looking at, because it's so sensitive, it can look at the voltage increase and decrease for each power stroke, and it can measure it for us. It doesn't work on every vehicle, and sometimes it will prompt you to turn the headlights on to get the alternator actually working. I found it works better on vehicles with good charging systems, good batteries in them. Some smart charging systems it doesn't work on, because at certain points of a smart charging system's life, the alternator won't be doing anything. So just be aware that it might not work on every vehicle, and Pico admit that as well. But basically, all you're going to do, cylinder balance, select the number of cylinders, and press start. So the engine normal operating temperature and idling. And all it does, it converts that voltage increase, decrease, increase, decrease to a graph that we can read. So if it works for you and you're chasing a misfire, you'll see which cylinder is down. And again, it will be cylinder 1, 3, 4, 2. All right. So there's two other, if we get back to, just quickly, we've got NVH and prop shaft balancing. So I'm not going into those two because these, again, are specialist pieces of hardware we have to buy and use with it. NVH is noise, vibration, and harmonics. And it's all about looking for noises in the vehicle and vibrations coming through the vehicle. And the kit that comes with it, it's quite good. It's a bit like Shazzy is, but it's a whole lot better. I believe, talking to some guys from JLR, Pico developed this for Jag way back when they were chasing noise and vibrations in their particular cars. Now, the other thing that the Pico diagnostic software is good for is prop shaft balancing. And again, there's another piece of hardware that comes with the tool. You need to purchase to use this prop shaft balancing. And it uses an optical sensor on the side of the prop shaft, and it basically looks for movement of the shaft vibrating as you're driving along. And then we can chuck a bit of weight on it, and we move the weight around the prop shaft to different locations to minimize that vibration. It's very, very clever that it can do that. And the fact you don't have to pull the prop shaft out of the car and send it away to an engineering company to actually balance it up. It's very, very clever. But we're not going into that today. There'll be a specialist course we'll run in the future. All right, so the next bit of software we're going to go to is the Pico 6. And that's the software I like to use. This is the be-all and end-all when we do our diagnostics. Okay, very quickly. So the first thing we're going to have a look at is the toolbar. So the toolbar is this one that runs along the top here. All right, so a lot of these, if you're using Pico at the moment and you know all this, fantastic. But sometimes even I tend to forget what a lot of the buttons do, especially to get around here to this 500 kilosecond. What is this one? I tend to forget that sometimes. But I'll just run through quickly what the buttons do. All right, so this first button here, I've just got to get my other screen up and running so I can see what it is. Because again, like I said, I'm suffering from old age short-sightedness or no-sightedness. All right. So this little button on the side, we can change between scopes. So we might have 2 oscilloscopes bolted into our computer or plugged into our computer, so we can achieve more channels, or we might be measuring 2 different things. And this little button allows us to change between scopes or to change to the demo software and back to our original scope. We might have an old 2-channel scope plugged in, and we might have a new 4-channel scope, which means we've got 6 channels we can measure. It just allows us to toggle between the 2. Now, the reason they do stuff like that is because Pico was not an automotive diagnostics company. They started in medical and sound, I think it was, and then they developed software to suit every different organisation out there. So it's pretty cool. So we get a lot of stuff that we may not use, but that's what it's there for in case you're interested. Okay, our next one is our auto set. Now, auto set I think is fantastic. It's when we're looking for a signal and we don't know what the signal should be. So we might be back probed into a sensor or an actuator of some description, and we're looking at feedback. And we don't know what our time base should be or what our voltage should be. So we back probe in, we hit auto set, and the scope picks the best voltage versus time. So voltage on this axis, time versus that axis. It picks the best one to display the pattern. Now, this is injector voltage. This is injector current. This is similar to that pattern there. But what it's done, it's just given us what it thinks is the best. What we can do then is we can go into our voltage and we can go into our time base and manipulate it until we see it in a format that we want, or in a size we want, or a number of pulses we want. But that little lightning bolt is our auto set. It's great for getting you in the ballpark. Okay, our next one, the little home button. So basically that returns to user default settings. Now, the reason we would press that is we might be playing around in automotive over here, and we've selected a current measurement using the low amp clamp, the 20 amp low amp clamp. But then all of a sudden we want to get back and do a voltage measurement on an injector. What we can do is click the home button, the user-defined settings, and it'll come straight back to whatever we had it on before we went into this automotive. And it's a great way. It sort of saves you a bit of time rather than going back through the channels, deselecting the clamps or the attenuators you're using. Okay, our next one across the toolbar is our time base. Now, Time base is across here. Now, when you look at the scope software, we've got these vertical divisions. And what time base is, it's the amount of time between divisions. So this is set on 20 millisecond divisions. So what that means is between every vertical line is 20 milliseconds. So 5 of those is 100 milliseconds. 20 milliseconds is great for injectors. You might decide to go a little bit smaller than that. You might decide to go down 10 milliseconds to increase the current size, the pattern size. But I find I tend to use 20 as my go-to because it gets me in the ballpark. If you're measuring live sensors, so real-time sensors, so if you're measuring an airflow sensor or you're measuring an oxygen sensor, something that gives back information in real time, or even a throttle position sensor, what you want is about 5 milliseconds per division. Sorry, 5 seconds per division. So we'll have 1 1000, 2 1000, 3 1000, 4 1000, 5 1000. So 5 seconds across there. And that's fantastic for oxygen sensors or anything like an airflow meter. So we crank the throttle and we want to see the airflow increase and then decrease as we hit rev limiter. 5 seconds is a great real-time measurement. Now, if you're measuring bus systems at all, like a high-speed CAN network or a FlexRay network, you want to be around 50 microseconds. And 50 is probably the best for a bus, a Bosch bus system. So control area network CAN would be around 50 microseconds. LIN is a little bit slower. Okay, our next one across here. Okay, this is our samples per second. Now, the best way to understand samples per second is thinking about the way the PicoScope actually graphs these diagrams. So what we're looking at, excuse me, the PicoScope doesn't draw lines, it draws dots, right? So it takes a sample, 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 and they're all dot points, right? But then it sort of fills in the gaps between the dots to give us this waveform. So what we're looking at here is the voltage waveform of an oxygen sensor, right? And we can see that. Now, that's set on 500 kilosecond samples. That's a lot, all right? That's a really high number. What we need to do is think about how many samples do we need for the particular waveform we're looking at. Now, a real-time sensor like an oxygen sensor doesn't need 500,000 little dots every second. It doesn't need that many. So what we can actually do is reduce the number of samples per second we take. So we just hit this little down arrow here and we drop that down as far as we go, all the way when we do an oxygen sensor. And that'll clean up our pattern a hell of a lot. It gets rid of all this interference that comes in from injectors and alternators turning and all that stuff. And all these little spikes is interference. The scope picks up absolutely everything. But reducing the number of samples per second cleans up a lot of that noise because it's not really, we're not interested in that noise. What we're looking for is the actual pattern of this O2 sensor. We want to see if it's switching from rich to lean or it's sticking in any particular place. So if I'm doing a real-time sensor like a throttle position, airflow meter or oxygen sensor, I want to set that as low as I possibly can. We don't need, like I said, 500,000 dots in a second. If I'm measuring CAN bus, in the other hand, or FlexRay, or most systems, then I do want that as high as I possibly can. We want as many little dots in that little grid as what we possibly can. Now, I say dots, but PicoScope displays it as a continuous line. But it's the way it samples. It's the way it actually pinpoints that on the grid. This one down here is the heater element on the oxygen sensor. So as we're switching across there, that's just our heater turning on and off. Okay, our next slide. All right, what we're looking at here is our waveform buffer. Now, waveform buffer is really, really good for reviewing waveforms that we've just captured. So this will capture 32 screens. So this is one screen here, as the pattern rolls in the next screen, it'll basically record to its memory 32 of those screens. Now, it helps if our time base is slow. So the slower the time base, the more information we get on there. Now, a good example, if I'm measuring a bus signal, so a CAN control area network signal on here, and I have my time base at 50 microseconds, I'm going to fill up those 32 waveforms or 32 screens. I'm going to fill that up in about 4 seconds flat, right? So you've got to think about the pattern we're trying to look at and the speed of the information we put on there. So if we slow our time base down to 20 seconds per division, I'll get about 5 seconds, maybe 10 seconds worth of display. If I slow that down to 100 seconds per division or 500 seconds per division, I can record nearly 24 hours of current flow or voltage signal on that line. And I might decide to do that if I've got the scope hooked up to a module overnight, if I'm looking to see a module that wakes up through the night and might be flattening my battery. And again, likewise, if I'm doing that real-time measurement and I've got my time base set fairly big, I'm going to slow my samples per second down as well. So keep that in the back of your mind. Yeah, so high sample rate, you'll get minimum pages. Low sample rate, you'll get maximum pages. Okay, our next button across the top, our zoom and grab controls, and these are pretty explanatory. You want to grab the picture and move to different locations. We hit a little grab button. If we just want to use our pointer, which is what I use most, with that little pointer selected, we can click anywhere on the waveform and the voltage or current flow at that particular point, the waveform will show up. Zoom buttons are quite clever. They don't zoom the whole screen, they zoom a portion of the screen. And they'll drop in a little box, a little zoom box that we can see, and we can then drag that zoom box around by using our little hand. And basically, it's only a very small sample that we zoom in on. Okay, the next buttons on our toolbar are our channel controls. Now, these channel controls are identical across all 4 channels in this particular scope. 2-channel scope, even though we'll have the 4 boxes there, but the last 2 will be grayed out because you're only using the 2 channels. But these controls are the same on all of them. Now, if we just drop down that box, first of all, so we drop down this little A box here. Now, inside here, we can select the probes, whichever probe we've got plugged onto the end. We can scale it, right? So if I'm looking at an ignition waveform versus an injector waveform, well, my ignition at idle will be around 5,000 volts, maybe 8,000 volts. That's going to go right off the screen, where my injector is only sitting at, like, you know, this part here is only at 14 volts. This part here goes up to about 100 volts. So what I can do is scale the pictures I'm looking at. So I can reduce my ignition waveform, bring it scale. We don't change the shape of the pattern or the size of the pattern. It's just its scale it reduces. And that's simply so we can fit it on the screen and compare it to other patterns. So we can look at ignition versus fueling at the same time. Offset is basically how far up and down the voltage scale or the scale on the side here that this line sits. Now, we can change our offset with these arrows, or we can also click on the value on the side, the numerical value, click on that and drag that up or down. And that's another way to change it. There's also in here active filtering. This is the good one. So if you get a dirty signal with a lot of interference, we can click on active filtering and then change the frequency at which the filtering occurs. Now, if we were to change that on a, let's have a quick look here. So here's our current flow through our injector. Here's our voltage in the injector. There's no filter added at the moment. If we go to our next screen, where we've actually turn the filter on and then increase that frequency up as high as we can go, you can see the voltage change ridiculously because we're on channel 8. Now, you can see we've lost a lot of our signal. We've actually filtered that signal out. So anything above sort of this range here Any frequency that goes above this range, we've filtered out by changing our value or frequency value inside there. So be very careful when you do use the filter that you don't actually get rid of the signal that you're actually trying to look for. So filtering's good. Okay, that's low pass filtering, that's called. Now, so we're just clicking down the probes here, and we're just looking at all the different probes that we can select. So the standard probe is multiplied by 1. So that's just whichever back probing tool or BNC lead and a back probing pin, we generally select it on times by 1. That's a 1-for-1 value. This is the PicoScope will display with attenuation. So this is times by 10 attenuation. So it'll actually increase the voltage or increase the scale by 10. So we might be measuring a very, very small voltage and we want to see it a little bit better. We can do that. Also, as we scroll down here, we can see the different clamps we can use, plus the pressure transducer as well. Now, what's interesting about this probe selection is the new PicoScope that's just come out, which I'm going to show you a little bit later. It's got some sensing, or it's got some smarts on the leads themselves, where whichever lead I plug into the scope in which channel, it automatically picks it up and enters that value in there. So it doesn't rely on us making a mistake. So I often plug in a low amp clamp, a 60 amp clamp, and it says 20 amp mode or 60 amp mode. And you've got to select either one of those when you do your testing with it. Like me the other day, I selected the 60 amp and I was trying to measure 20 amps, and I just kept going off the scale. And I'm going, I couldn't work out what was wrong. I was flicking the button on the tool. Didn't make any difference. But it was because I'd selected the wrong tool inside a little drop-down box. The new PicoScope will automatically fix that for us. It selects the right tool. Whichever one I've got plugged in, it'll select it. And I'll show you how it does that later. All right, moving on. Next part of our software is our lower toolbar. So we've got on this side, we've got our begin, stop, and capture buttons. So that's basically play and stop. I fall for this a bit where I'm trying to take a waveform and my button is on stop. So it won't record a waveform. And I'll be sitting there and probing, going, why isn't this working? And it's because I haven't come back down here and hit the record or begin capture button. So keep an eye on those two. The other thing it allows us to do is to capture a waveform. We can be looking at the waveform. We can just hit stop, and then we can sort of let go of whatever we're doing and then come over and analyze the waveform on the screen. So that's very handy as well. The next little drop-down box here is our trigger. And the trigger is what allows us to set a trigger somewhere on this waveform. So we either begin capturing from that point, or that's our minimum voltage point. We can choose what channel the trigger is on. We can choose the type of trigger it is, whether it's a rising rate or a falling rate trigger. So triggers are pretty cool. We cover that a lot in some of the advanced diagnostic or advanced PicoScope classes we do. Okay, I've got to keep looking at this screen because that's where I've got everything written down, because I can't see it on this one. Let's make my screen a bit bigger. Okay, vertical rules. Sorry, a bit dry. Okay, so on the far right of our screen, we've got these, the little green ball on this far right, and we can drag that green ball across. And there are vertical rules. And vertical rules are pretty good. What I might do is just open up, let me screen share. Screen 2, share. All right, here we go. So we've got an injector pattern carrying on here. I'll just quickly put a trigger, repeat. Now you can see my trigger is set down at 0, so there's no pattern before that. If I just drag that diamond up, I can hold my waveform in place. So that's a fuel injector waveform. Now, if I grab on the bottom right-hand corner, these are my vertical rules. And I can pull that across there, pull that across here. There we go. And you can actually see I've got these rules set on degrees. So if we come down and click on the rules, and you can look at my little drop-down box here, you can see I've got one rule and I've set on degrees. So I can then change that to a percentage. I can change that to a custom value and put whatever value I want inside there. So these are they're vertical rules, but I use them as degree rules. And I use them a lot when I'm doing camshaft to crankshaft measurements. And they're rules, vertical rules. Now, if I put that back over this side, I'll grab my vertical rules on the left. Now, these are the square boxes. Now, we put first rule there and second rule over here. Now, straight away, you can see that I've had a box come up in the center of the screen. I can move that box around a little bit. So this number 1 is rule number 1. This is the first one I dragged, and you can see it changes the value of number 1. And what that's doing is taking a measurement from 0 over to here, and that's giving us a measurement there. Number 2 gives us a measurement from 0 to there. No worries at all. But the one I'm really interested in is the difference between the two, and that's my delta. And here's my delta over here, 1.04 milliseconds. So if I was looking at this as a fuel injector, I'd go, yep, that injector's open for 1 millisecond. Now that's pretty small. So this would be a very, very small engine. On average, fuel injectors are around 4.5 milliseconds at idle. So this thing could just be a very, very small engine. All right. So we just click the close box to get rid of those rules. Now let's get back to my slideshow. And start. All right. So we're looking at those rules on the right-hand side as our degree rules and our vertical time rules. Or rulers. It doesn't really matter which one you call it. Okay, these are the degree rules here that I was talking about. So this waveform is of an engine running. So we've used the pressure transducer in cylinder number 1, and we've taken a reading of the engine running. Then I've dragged these vertical degree rules over. I've put 4 of them in place simply by going into rules, clicking on that button, and then selecting times by 4 rather than times by 1. And because it's a 4-stroke engine, I've got 0 degrees there, and I've changed that value to 720 degrees. The reason I've done that, it basically allows me to look at a full 4 strokes of this particular engine. So I can see here as my pressure goes up in the cylinder, top dead center, compression number 1. So that'd be 0 degrees. And then as the piston drops down 180 degrees, I'm at bottom dead center number 1. Now I can see my values drop down there. So the engine has slightly gone into vacuum at that point. Now that would be our power stroke down there. So compression stroke, ignition, power stroke down. Then the piston starts to come back up again, you can see. So we've come out of that vacuum, we come back to atmospheric. So what happens after our power stroke? Our exhaust valve opens. And that's why this value here is back at 0. Because our exhaust valve's open. So we're no longer in vacuum in that cylinder. Exhaust valve is open all the way across to here. And somewhere over here at this bit of noise, our intake valve opens, we can see. So the exhaust valve closes about here. Intake valve opens. The piston's now at 180, what's that? 360 degrees. So the piston's now back at top dead center with the intake valve opening. The piston's now on its way back down again. For our intake stroke, we can see the pressure in the chamber reduces as the piston drops back down. And somewhere around here, the intake valve closes and the piston starts to travel back up the top again, so intake stroke. So it's a good way for me to look at crankshaft position, looking at the pistons, and looking at this bit of noise here. It's a good way to look at valve timing. So the software is pretty strong. We've done this a few times, this particular test. It works very, very well. Okay, so we're still in Pico 6 software. Let me just get my other one back up the screen so I can see what's going on. Right. We're going to quickly look at we're going to look at two tests that we can do using the PicoScope software. And they're two really good tests, but I'm going to show you how we can get to them pretty easily. So, first thing we do, if I want to do a fuel rail pressure test, there's my fuel injector happening up there, I'm going to go up to automotive. Now, the reason I do this is because I can never remember what time base versus voltage plus what connections I need to use. I just can't remember it. So what I always do is go up to automotive, drop down box occurs, we go into sensors because I want to do a fuel rail pressure sensor test. So I go into sensors, come down here to fuel pressure, common rail diesel, click on that one. Now, two things happen with the software. First thing that happens is this web browser page pops up, it goes back to the Pico website, and the software tells us exactly how we're supposed to perform this test, which is quite clever. So Pico's got it outlined. They show us what channel to hook up, which wire to go into, which signal we should put a ground, and then it walks us through how to actually perform the test. So when we get back to our actual software, here's the test we've done. We followed their instructions. Now, the instructions actually say there, again, I can't quite read this, but it says, crank and start the engine, let it idle for 5 to 10 seconds. Then depress the accelerator pedal to its maximum and hold for 2 to 3 seconds. Release the accelerator and let the engine idle for another 5 to 10 seconds and turn off the ignition. So they've given us instructions on doing this actual test. Now, what happens straight away, the software presets to 5 volts there, and our time base is set at 5 seconds per division because this is a real-time test. And that's done automatically because we've selected that test from automotive. Now, the good thing is that fuel rail pressure test on a common rail diesel, it is the same for all rail pressure sensors. Exactly the same. The voltages are the same. What we should see here is exactly the same. We do see some differences when we've got a twin piston pump, like a Denso pump, versus a 3-piston pump, which is like this one is. Our pressure values are a little bit different inside there, but essentially the test is identical. And the 3 points we look at when we do this test. So over here, we've got ignition turned on, but nothing much happening. We can see we're around 0.5 of a volt sitting on that one. Let me just get my screen a little bit bigger. Yeah, so we're sitting around 0.5 of a volt, 0.6 of a volt with the ignition on. Now at this point here, we're actually cranking the engine. As we crank the engine, the fuel pressure increases. And that's rail pressure, so our pump's obviously doing what it's supposed to do. The suction control valve is obviously doing what it's supposed to do. Now, at this point here is when the engine starts and idles. So we've let the engine idle for about 5 or 10 seconds. So you can see down the bottom here, 5, 10, 15. So we've given about 10 seconds worth of idling. At this point here, we've depressed the accelerator all the way to the ground. And that's what we're seeing. We see the ECM pull the suction control valve open to let maximum fuel through, which ramps the fuel pressure up in the pump or in the rail. And we see that top out here around the 3.5 volts, 3.6 volts. Now, all of these should be the same. They should all be around that 3 to 3.5 volts. If you're not getting this massive spike, you've got a problem. You've got a pumping problem or a suction control valve problem. Now, from this point here down to this point here, now remember my foot's flat on the accelerator. What's actually happening is the engine's gone into rev limit and it's gone, hang on, we're in neutral. He's sitting there with his foot on the brake. Why do I need to apply all this fuel? We don't need it. So it brings the RPMs back down by reducing the fuel pressure, and that's what it does. And this point here is where a common rail diesel sitting there at rev limit at probably 2,500 RPMs. So you can see I've held it open for about 5 seconds, which is what the instructions said. Then I've backed off the throttle. Now, when I back off the throttle, I should see that fuel drop down, and it should ramp back down to our idle pressure. Now, if I don't see that ramp back down nice and smooth, I've probably got, if I get a jagged edge across here, that could be my suction control valve sticking. Or I might see it stay up there when I back off. And again, that's the suction control valve sticking. That's a good way to test the valves. Again, I let the car idle for another 10-15 seconds. Then at this point, I switch the engine off. And I should see the fuel pressure drop instantly, because the minute that pump stops turning, that pressure should come straight back down to this point here. Now, you'll actually see that this point here is still a little bit higher than what we were on this side. And that's because there's still some residual pressure in that rail. And that residual pressure is because all my injectors are closed. What I should see over time, which is over the next 5 seconds, I should see that fuel pressure slowly bleed off, right? I shouldn't see it drop all the way back down to that 0.6 volt like we did here instantly. If I turn that engine off and it drops all the way back down there, then I've probably got a leaking injector. And that's the best way we can see. This car was good. So we've seen the fuel pressure bleed off really slowly. And this point here is where the ECM has actually shut down and removed power from the fuel rail pressure sensor. So that's a pretty good test. And that was just using automotive software, the automotive section or the automotive drop-down box to settle that up for us. The good thing about Pico software, it's self-explanatory. It tells us what to do every step of the way. It's not going to solve all the problems, but it will help. So the next test we'll have a quick look at is a piezo injector test. So you can see we've just done our fuel rail pressure test there. Again, let's go to automotive, come down to actuators because an injector is an actuator. Come over here to injected diesel, and we get to choose whichever injector is in this particular vehicle. So this is a piezo injector. So it's only given us one value, and that's a current value. All right, so then we click on that, select next. Straight away, oh, excuse me. Straight away, instructions come up, tell us how to perform the test. Low amp clamp, the 60 amp clamp, and set on 20 amps into channel 1. Now, I usually do, whenever I do this test, I use channel 2 or channel B as well, and I look at the voltage on this particular vehicle as well as the current flow. And it actually tells us how to start the engine, not how to start the engine, but it tells us what to do once we've started the engine and what to look for in the pattern. Now, the other thing that you can't see on here is that if you scroll down a little bit when you go into automotive, it actually gives us sample waveforms and a description of the waveform, and it shows us what we should be looking for. And basically, if you're not getting that, there's a problem, and it gives you some hints or tips of what might actually be happening. All right, so here you can see, here's our current flow in our piezo injector, and you can see this is only drawing about, I don't know, about 6 to 8 amps fully open, and then 6 to 8 amps fully closed. Now you can see the current reverses. So we go into the positive current to open the injector, and then that injector is basically held open from here all the way over to here where it closes, right? And all that is the bidirectional drivers inside the ECM just swapping the current flow over. So we open it, we hold it open for, 4 milliseconds, or actually, no, this is a diesel, so a lot less. We could measure this. We hold it open for a certain amount of time, and then we reverse the current flow to close it. Now, the reason we look for current flow in a piezo injector is because if the piezo crystals fail, if they go open circuit, there will be no current flow. So we might have a misfiring injector or a misfiring engine, and we basically put our current clamp on it, away we go. We can do that on each injector, and we can see which one's misfiring just by looking at the current flow. Piezo injectors do fail. Now, they can fail electronically, in which case the piezo stacks can die, or they can fail mechanically, in which case the spring dies on the mechanical side of the pintle, and it'll either, the injector will stay open, or the injector just won't, it'll jam and it won't open at all. Now, if you have a mechanical failure, we'll still get this pattern. It's not the changes. This one we always have, if we have mechanical failure, we'll always have a piezo current flow displayed. Now, if I go to my next screen, you can see I've got a voltage trace there on channel B. And this is the way I like to look at it. Because when I look at voltage, so the red's the voltage, the blue's the current, I like to look that the ECM is applying the right voltage at the right time. So yes, the ECM is applying voltage to open the injector and then close the injector. You can see that that point we ramp the voltage up to open it, we hold the voltage there, but inside the ECM, we actually reverse the current flow. So the voltage remains the same, but the current flow changes. And the idea of looking at voltage tells us that the ECM is actually sending a signal. The current flow tells us that the piezo injector is responding. So again, we got to that by simply clicking on automotive and following the instructions. All right, we're getting there. PicoScope 7, tablet version. So I don't want to spend too long looking at the all the different in-depth features of the software on Pico 6, because we've still got to get through 7. But 6 is the one you want to use for your in-depth diagnostics. Pico Diagnostics is your quick testing, your battery, your relative compression, your absolute compression, your balance tests. They're the ones you want to go to in a hurry. So they're the ones that will get you, within 5 to 10 minutes, you'll have done all those tests. And that'll give you an idea when you need to do your in-depth testing. So then you go to Pico 6, follow the instructions. What I want to show you on Pico 7, it's quite different. So the layout's a little bit different. So what I'm going to do is open my screen. I'll just screen share. Here we go. So, yes, there it is. So as soon as you open Pico 7, this is the this is the test or the light version, and this is what works on tablets. What we can do, we can click on charging and starting. So this is the same as going to automotive in Pico 6. We go to charging and starting, relative compression, gasoline compression. Just click on links, the purpose of the test. It gives us the guide and settings file. So if I click on that, up we go. So straight away you can see my values over here change. So it's presetting the software. So again, it's like going into automotive. Now what it should also do, which it hasn't done at this point, is open that other guide. Oh, there it is. I was wondering when it happened. And here's my guide. So this is exactly the same as what we'd see in Pico 6. And tells us how to do it, shows us a sample waveform, and gives us some information what could be actually wrong if we're not getting those waveforms. It's a very, very powerful tool. All right. Now, we can see that the software is different. So up here, we've got our start, our stop, and our run button, where we originally had it down the bottom here. There we go, we stopped that. Time-based, trigger, they're at the top. Guided tests, so this is where we go through how to perform the tests, our waveform library, waveform notes. Auto setup, so the icons are a little bit different. We can open save files, we can save a file, we can print a file, we can enter vehicle details. It is a light version, so it's not quite as powerful. It doesn't read quite as in-depth, but probably for 90% of what we actually do, it's pretty good. There's a lot of maths channels here. I tend not to use maths channels. I know there's some really, really good PicoScope users out there. Frank Massey's one of them. And they'll live and die by the scope, and they'll do everything with it. I'm not that good, so I tend not to use a lot of this stuff. Here's our measurements. So we can look at our time, our voltage, our reference waveforms. We can actually go through and select them based on, there we go, alphabet. More, here we go. So a lot of these little icons are the same icons we might see in PicoScope 6, but the setup's a little bit different. And the reason they've done it that way is because it's mainly due to be used on a tablet. So Pico 6 isn't a bad, oops, I'm zooming in and out here. Let me zoom out a little bit. Get rid of that zoom. Guided tests. Example waveforms. No, I want to get back out of this. Auto set. There we go. So it's actually trying to pick, I'm on demo version here, it's trying to pick the best waveform for that cranking test. All right, so if you get a chance, download this, pop it open, have a play with it. It's okay. It's all right. I mean, I've used it on and off, but I still try and use the PicoScope 6 software. Here we go. Here's our channel A. We click on channel A. We can actually change our probes. AC or DC. We can invert the signal. Again, it's not quite as in-depth as the Pico 6, but we can use it. So there we go, channel A off and stop. Let me minimize that one. Now, where are we? Back to slideshow. And stop, start. Takes a minute to get back to it. So there's the Pico 7 software. Again, tablet-based. If you've got tablets and use tablets in the workshop, you can upload this on there. It doesn't take a lot of room. But what I do find is, remember, your PicoScope uses power from the tablet, or it uses power from your computer to operate. So the Pico box itself sucks a lot of current out of the computer, whatever you've got it plugged into. If you've got it plugged into a tablet, it can drain the battery pretty quick on a tablet. So make sure the tablet's fully charged, or if you're using a tablet, make sure the charge pack's plugged in. That's all I can suggest. Otherwise, just use it for quick testing where you're not got it on there for an hour or two at a time. We did that. All right. Here is the new PicoScope. So this is the 4425A. This is the 2-channel, 4425. This is the 4-channel. This is just an old 8-channel PicoScope, right? So we generally only use the first 4 channels. You know, we buy our automotive scopes. We tend not to use more than 4, but they do sell an 8-channel one. Now, you can see our BNC connections across here. They're just color-coded. Now, the problem is, if I'm looking for channel A and I accidentally plug into channel B, and then I'm back on my software and I'm trying to read a waveform on channel A, it's not going to be there because I've accidentally plugged in the wrong one. Or maybe, like I did earlier, and I plugged the wrong probe in. And I had the probe set wrong. Well, see these little optical sensors down here underneath the BNC connectors. The new 4425A will detect exactly which probe or which lead you've got plugged in, and it presets the software on the Pico 6 or the Pico 7 to suit whatever you've got plugged in. So if I do automotive, like I go through to my guided test and it tells me to plug this one in, if I plug into the wrong channel, the Pico will automatically swap channels and do the value on channel B rather than channel A if I don't have it plugged in right. It is pretty good. It's about the only hardware difference between the two, where it just picks up whatever we've got plugged into it. So it could be a bit of a time saver. The other thing is the new 4425A amp clamps don't require a battery. They draw their power directly from the scope itself. So if you're like me and you forget to turn the amp clamps off at the end of the day and the little 9-volt battery inside them goes flat for the next time you use it, you don't need to worry about it anymore with one of these, because the scope itself powers the amp clamps, which is a pretty good thing. And again, it's done through these little contact pads. All right, excellent. Channel status light show you which probes and channels to connect, and their status here. Excellent. So we've talked about that. All right, well, that was a pretty full-on 1 hour. There is a lot more to the software than what we've covered in that 1 hour. There's probably about 5 days worth of solid learning on the PicoScopes. So what we've looked at tonight is your basic setup, your basic toolbars, some of the time rules. Very, very basic on the triggers. Like I said, we cover that a little bit more in another course. But it should help you navigate around the three different software options that we've actually got from Pico. So that should wrap up our little bit over an hour, which is good. I'm getting better at this. If you've got any questions, I'll hang around for the next 15, 20 minutes and I can answer those questions. Otherwise, if you want to download the presentation from tonight, the files, you can certainly do that. We're sharing it now. A heads up for next Wednesday, we're doing some actuation tests with the scope. So I'll pre-record those out on my driveway. And we'll basically run through, and that's using the Drive Pro or the Elite kit that we sell to drive an actuator. So we might drive a window motor, we might drive an EGR valve, we might drive an injector. I don't know. I'll work out whatever it's going to be before next week. And we'll look at the PicoScope. So we use the scan tool to drive it, the PicoScope to measure it. And the reason we use a scope to measure what's actually happening in an actuator is because we see it in real time and we see what's actually happening down at the pointy end. I know we can look at a scan tool and we can go, yep, open EGR, and we rely on the feedback from the EGR to tell the scan tool how many % open it is. Sometimes we know that's not true because the sensor, the position sensors can fail inside there or not read properly, and that's why we're triggering fault code. So the idea of the scope, it rules out the feedback option. We just read what's actually happening down at the sensor, and we're not getting any modification from the control unit itself before it gets to the scan tool. But that's what we're going to cover next week. So we'll be about an hour doing that, and we'll do 4 or 5 different type of actuations and different tests. So that'll be the same time next week, 7 o'clock to 8 o'clock. Okay, and on that bombshell, I'm going to wrap it up. Tonight's session has been recorded, so if you do want to download it, it'll be available on our website. So if you go to the AutoLogic website, you can click on the link. And the last 3 or 4 we've done as well, they're all up there ready to download or replay and watch as you feel fit. Now, yeah, if there's any questions, pop it through. Hang on, I've got one there. Send me the link and I'll forward it on. No worries, Pat, I'll send you the link. I'll do that before I get my next cup of coffee. All right, so if there's any questions on tonight, what we've covered? Okay, nothing's coming through. I'm going to turn my camera and microphone off. So I hope you all have a nice night. Go and have a cold beer and dream about PicoScope software. Until next week, I will hang around and I'll answer questions in the chat box.